Let's continue with the next type of triangles, right isosceles triangle. Definition: a triangle that is right and isosceles at the same time is called a right isosceles triangle. In this figure, we have a triangle CAB. It has a right angle of vertex A, angle CAB equals 90 degrees. It also has two equal sides AC and AB. So this triangle is right and isosceles at the same time. We call it a right isosceles triangle. So ABC is a right isosceles triangle at A. A is the main vertex. In this next example, we have a triangle ABC, but this time the angle of vertex B, angle CBA equals 90 degrees, and it has two equal sides, BA and BC, so this is a right isosceles triangle at B. ABC is a right isosceles triangle at B. Here we have this also right isosceles triangle, because here we have this code of the right angle and we have this same code on these two sides, so they are equal. So this is also a right isosceles triangle. If you notice, the right angle doesn't have to be here drawn down. No, it can be any angle. Important properties. In a right isosceles triangle, the base and the hypotenuse are the same. Of course, here AC is the hypotenuse of this right triangle. Also, it's the base of this isosceles triangle. So AC is a base and hypotenuse at the same time. Same here for CB. CB is the hypotenuse and the base of this right isosceles triangle CAB. The acute angles in a right isosceles triangle measure 45 degrees each. So here, if you notice, these two acute angles, they are also the angles at the base in this isosceles triangle, and they are equal. And since the two acute angles in a right triangle are complementary, their sum is 90 degrees, and they are equal, so 90 divided by 2 equals 45 degrees each. Also, in this right isosceles triangle ABC of vertex A, also the two acute angles are equal. They are also the angles at the base. So in any right isosceles triangle, the two acute angles are always equal to 45 degrees each. Now let's continue with the last type of triangles, an equilateral triangle. Here in the word equilateral, we see equi, it means equal. What's equal in an equilateral triangle? The three sides are equal, and also the three angles. Equilateral triangle, three angles, also they are equal. So the general definition, an equilateral triangle has three equal sides. Examples, here we have this triangle KLM. Here we have the same code on the three sides KL, LM, and MK. So the three sides are equal, and we call it an equilateral triangle. Let's look at the second triangle, CAB. It also has three equal sides, CA, CB, and BA. And also here we notice that the three angles are equal to 60 degrees each. Why? The three angles in an equilateral triangle are equal, and since the sum of the three angles in a triangle is equal to 180 degrees, so we divide 180 divided by 3 equals 60. We obtain 60 degrees for each angle. So the three sides are equal and the three angles measure 60 degrees each. Here we have AB equals AC equals CB equal 5 units. Important properties. In an equilateral triangle, the three angles are equal, and each angle measures 60 degrees because 180 degrees divided by 3 equals 60 degrees. no matter what's the length of the three sides. It means if we change the length of the three sides of this equilateral triangle, the angles will always be equal to 60 degrees. Let's see an animation now to prove why, if we change the length of the sides, why the angles will remain equal to 60 degrees each. In this figure, we have an equilateral triangle such that its three sides, A, B, and C, are equal to 3 units each, like for example 3 centimeters each. It's an equilateral triangle and the three angles are equal to 60 degrees each. Now if I make the three sides equal to 4 centimeters each, you will notice that the three angles will remain equal to 60 degrees. 5 centimeters each also, the three angles will remain equal to 60 degrees. Now if I change into 6, same, into 9 centimeters each, also the three angles will be equal to 60 degrees each. To 12, for example, the three angles will stay equal to 60 degrees. So it doesn't matter what is the length of the three equal sides in an equilateral triangle, the three angles will always be equal to 60 degrees each. In this figure, let's get back to it. We have angle CAB equals angle CBA equals angle ACB equals 60 degrees. Now attention, an equilateral triangle doesn't have a main vertex. In an isosceles triangle, we had two equal legs and the third side had different length. Here, no, we have three equal sides, so we don't have a main vertex because the main vertex is the intersection of the two equal sides. In fact, the three vertices here are all main vertices, so we don't have a specific main vertex. Remark, an isosceles triangle that has one angle of 60 degrees is in fact an equilateral triangle. Let's prove it together. Here in this figure, we have this isosceles triangle ABC because it has two equal sides. Now let's try to make this angle at the main vertex 45 degrees. Let's make it equal to 60 degrees while keeping these two equal sides at the same time. So if you notice, once this angle of the main vertex is equal to 60 degrees while keeping these two sides equal, the two other angles will remain equal to 60 degrees, and it's in fact an equilateral triangle. So in an isosceles triangle, if the angle at the main vertex is equal to 60 degrees, the two angles at the base, what will remain is for them is 180 minus 60 equals 120, and since they are equal, we divide 120 by 2, where each one will be equal to 60 degrees. If one angle at the base in an isosceles triangle was equal to 60 degrees, the other angle at the base will be also equal to 60 degrees because the angles at the base in an isosceles triangle are equal. Their sum is 120. What will remain for the angle at the main vertex is 180 minus 120 equals 60. So in all cases, the three angles will be equal to 60 degrees each, and it will become equilateral. So an equilateral triangle is in fact an isosceles triangle that has one angle of 60 degrees. Now let's solve this exercise, practice page 43, number 5. BEL is an isosceles triangle of main vertex E, such that angle BEL equals 70 degrees. So here they gave us the measure of the angle at the main vertex of vertex E equals 70 degrees. EB and EL are equal, they have same code, they represent the legs. And BL is the base of this isosceles triangle because it's opposite to the main vertex E. Verify that angles BLE equals angle LBE equals 55 degrees. So they gave us the angle at the main vertex. They want you to calculate the two angles of vertices B and L. It means the two angles at the base, we need to calculate their measure and prove that they are equal to 55 degrees each. How? So we know that the angle at the main vertex is equal to 70. What will remain for the two other angles is 180 minus 70, because the sum of the three angles is 180 degrees. 180 minus 70 equals 110 degrees. And since these two angles are equal, we divide 110 divided by 2, we will have 55 degrees. So BLE equals LBE equals, but we open the parenthesis, we do 180 degrees minus the angle BEL, angle at the main vertex. Then we divide the answer that we obtain by 2. Why? Because the base angles of isosceles triangle BEL are equal. Then we replace BEL by its measure equals, we open the parenthesis, 180 degrees minus 70 degrees divided by 2 equals 110 degrees divided by 2 equals 55 degrees. So this is how we calculate the two angles at the base in an isosceles triangle in case they gave us the measure of the angle at the main vertex. So this is the end of this video. Thank you for watching.